Welcome to This Explainer. Today, we're diving deep into humanity's absolute obsession with the sky. From ancient Native American rain dances to European farmers literally firing cannons into storm clouds to break up hail, we've spent centuries wanting to master the storm. Fast forward to today, and our methods look completely different. We're launching advanced satellites, building massive supercomputers, and training artificial intelligence to map out our entire atmosphere. But through all of this technological advancement, the ultimate question really remains the same. Are we actually moving toward a future where we can truly command the weather? Let's find out. To understand why this topic is so incredibly urgent, we have to look at the sheer scale of the impact weather has on us. Every single year, extreme weather events cause hundreds of billions of dollars in global disaster losses. Just think about massive events like Hurricane Katrina or Hurricane Ian. We're talking about single storms causing well over $100 billion in damage each, wiping out entire communities in just a matter of hours. Add in terrifying lightning storms, deep droughts, and catastrophic floods, and the economic and human toll is absolutely staggering. This isn't just a minor inconvenience, It's one of the most significant financial and humanitarian crises of our modern era. So that brings us to the trillion-dollar question. If we know these disasters are coming, could humanity ever step in and stop them before they begin? Imagine the sheer hubris of building a physical switch to just turn off a hurricane, balanced against the desperate humanitarian hope of saving thousands of lives, or dropping rain on dying crops. It sounds exactly like science fiction, right? But the reality of how we interact with the atmosphere is far more complicated, far more nuanced, and frankly, a whole lot more fascinating. First things first, we've got to clearly define the fundamental difference between weather and climate. Weather refers to the short-term, immediate, and incredibly chaotic conditions happening outside your window right now. Is it raining? Is it windy? Is it hot today? Climate, on the other hand, is the long-term, stable, and predictable pattern of those atmospheric conditions over decades. You can kind of think of weather as your current mood and climate as your overall personality. Intervening to cheer someone up from a momentary bad mood is a quick, localized fix. But trying to fundamentally alter an entire personality? That requires a massive, systemic overhaul. The exact same principle applies to the sky. When we're dealing with weather, we're engaging with what I like to call the atmospheric machine. Earth's atmosphere is, without a doubt, the most powerful machine humanity has ever studied. And it relies on an incredibly complex, interconnected balance of pressure systems, intricate levels of moisture, intense temperature gradients, and global winds. This is where chaos theory and the famous butterfly effect come into play. The atmosphere is so deeply interconnected that a slight temperature shift in the Sahara Desert can directly influence the formation of a massive hurricane in the Atlantic Ocean months later. You pull one lever, and a dozen totally unpredictable things happen globally. Section 1. Weather Modification Today, Science versus Fiction. Okay, so what can we actually do right now? Well, we do have some operational technology today, specifically the cloud seeding process. And this is not experimental, it's a proven method being used right now. First, an aircraft flies directly into an existing storm system and injects a substance called silver iodide. Why silver iodide? Well, its microscopic crystalline structure closely resembles natural ice. So this actually tricks the atmospheric water vapor, giving it a perfect little scaffold to freeze and condense around. Once those water droplets get heavy enough, artificial precipitation falls to the ground. We are essentially giving nature a highly specific chemical nudge to make it rain. And look, this isn't just theory. It's heavily utilized globally. Organizations like the UAE National Center of Meteorology regularly use rain enhancement to pull much-needed moisture down into arid regions. Ski resorts and global water agencies utilize snowpack generation to manually build up their winter reserves. And perhaps most famously, China used massive, highly coordinated cloud seeding operations just before the 2008 Beijing Olympics. They literally forced incoming storms to rain out before they reached the stadium, ensuring perfectly clear skies for the opening ceremony. So we've mastered the art of wringing a little extra water from a passing cloud. But here's the thing. Making it rain locally is just a tiny drop in the bucket compared to what comes next. Squeezing a cloud is completely different from taming the massive, global atmospheric machine. Section 2. The AI Forecasting Revolution. This is where things get truly mind-bending. For decades, we relied on traditional numerical weather prediction. That meant using room-sized supercomputers to crunch incredibly dense fluid dynamics and physics equations step by step. It was brute force, and it often took hours to generate a single forecast. Today, we're shifting to AI Earth models which act as highly accurate digital twins of our planet. These artificial intelligence models don't just solve complex physics equations. Instead, they're trained on over 40 years of historical global weather data to instantly recognize vast, hidden atmospheric patterns. We're talking about generating highly accurate forecasts in a matter of seconds. Think about the evolution of how we observe the sky. It's been absolutely staggering. In the 1960s, NASA and NOAA launched the very first weather satellites, effectively taking blurry Polaroids of clouds from space. By the 1990s, advanced Doppler radar allowed us to track local storms in real time, and the 2000s brought those supercomputer climate simulations. Now, in the 2020s, AI forecasting models like Google's GraphCast or Huawei's Pengu Weather are quite literally outperforming traditional physics-based models in tracking actual hurricane paths. We can now simulate the entire global atmosphere in real-time, high-definition predictive models. Section 3. Could we stop natural disasters? So, with all of this incredible AI data, we have to look impartially at the established science and separate our hopes from reality. Can we predict massive hurricanes and catastrophic floods? Yes, with staggering accuracy days in advance. But can we stop them? It is scientifically impossible. Even with tornadoes, where we can predict them minutes to hours ahead of time, stopping one remains pure fiction. We have gained this phenomenal, almost godlike power to predict the future of the atmosphere, but we possess absolutely zero physical power to intervene. The atmosphere is far more unpredictable and powerful than it appears to the naked eye. To really put this in perspective, a fully developed mature hurricane releases heat energy equivalent to a 10-megaton nuclear bomb exploding every 20 minutes. Human intervention against that incomprehensible level of kinetic energy is totally impossible right now. We simply cannot fight nature with brute force when its forces are that immense. Section 4. The ultimate ethical dilemma. Because we simply cannot stop extreme weather locally with brute force, some scientists are looking at experimental climate interventions. This is often called geoengineering, and the goal is to control the entire global system. Take solar radiation management, or SRM. The concept here is to reflect sunlight away from the Earth to rapidly cool it down. Scientists actually got this idea from observing real-world volcanoes, like the 1991 eruption of Mount Pinatubo. That natural event pumped enough sulfur dioxide into the stratosphere to cool the entire Earth by about half a degree for a full year. There's also carbon dioxide removal, which means actively sucking carbon out of the atmosphere on a massive scale. However, major organizations like the World Meteorological Organization and the IPCC impartially point out that these interventions carry severe risks of unintended consequences and unparalleled environmental disruption. One massive fear among scientists is a concept called termination shock. This is the terrifying risk that if we start artificially cooling the planet by spraying aerosols into the stratosphere, and then for some political or economic reason we suddenly stop, global temperatures wouldn't just rise slowly. They would spike violently in a matter of months, devastating global agriculture and ecosystems worldwide. Which opens up an incredibly complex geopolitical and international law nightmare. What happens if one nation, or perhaps a coalition of island nations facing rising sea levels, decides to unilaterally deploy solar radiation management to protect their own citizens? Who truly controls the weather? And what if that unilateral action successfully cools the globe, but accidentally shifts the vital monsoon season away from India, threatening 1 billion people with massive crop failures and famine? Right now, there is absolutely no international governing body equipped with the framework to handle these disputes. It makes geoengineering as much a political landmine as a scientific one. We've taken a massive leap from ancient rain dances to running digital twin Earths on our servers. The future is arriving faster than ever, driven every single day by advanced AI forecasting models in new constellations of space-based observation satellites. Because our technological capabilities are accelerating at such a breakneck pace, these theoretical geopolitical and ethical questions, they're going to become very real very soon. We are peeling back the layers of the atmospheric machine faster than any other generation in human history. We spent centuries looking up at the sky, wishing we could command the storm. But now we realize the ultimate power isn't in changing the weather, it's in knowing exactly what the sky will do next. The future belongs to those who understand this beautiful chaotic machine well enough to safely live alongside it, not those who try to blindly command it. The real question is, are we wise enough to handle the immense responsibility of the knowledge we're uncovering? Thank you so much for joining me on this explainer, and keep looking up.
Thanks for watching World Decoded. Make sure to like and share, subscribe, and stay curious.